Well, guys, welcome back to Flowco e-learning series 5, Plunger Lift 101. I'm Matt Young, and I'm joined with JD Spencer today as our guest host. Thanks for joining, JD.
Yeah, glad to be here.
Yeah, definitely. So glad to be getting back into these. I think, let's see, we're on 4 technical and 1 non-technical so far this year. And we've got a couple more to kind of finish up the year. So glad you're here and get to talk about plunger lift today.
Yeah, let's do it.
So, guys, so today is a technical presentation about plunger lift. We broke this one down into a 101 series. We'll follow it up with a 102 series here in a couple weeks. But really, the main thing is, of course, to have JD here, technical representative, extensive knowledge and expertise in plunger lift. Made the drive up here from South Texas. So thanks for attending, and look forward to getting your input and maybe a couple arguments from you about
punch lift. I'll do that.
Oh, good. That's what I want. So, but really today, the concept, what we want to talk about really is going to come down to just what plunger lift operations are. How does a plunger lift work? What is its purpose from an artificial lift standpoint? We'll also get into some well selection based off of critical velocity, gas to liquid ratio or GLR, and then also total liquid rates, right? Yeah. We'll get into some of the different plungers that are out on the market and how you can pick your well type or your plunger lift equipment based off of your well type. We'll go from like the popular bypass or continuous flow plungers back down to just a simple bar stock conventional style plunger. So get to go through the whole setup. We'll touch on installation, some key components, SOPs that operators should follow when they're ready to prepare their well for plunger lift. And let's see, make sure I didn't miss anything else. And then go over the cycle times. How do you operate a plunger in what we call cycles, right? And we'll get into a lot more details on that. But as a plunger lift operates, it has different modes or cycles to make sure that it operates correctly. And we'll get into maybe some of the data that you can track as an operator to make sure that your system's operating correctly, right?
Yeah.
So perfect. Couple things before we get started. Of course, this training is going to be recorded. We'll post that up on our training site at flowco.com. So if anybody misses it, if they have anybody else that wants to join in or see it later on, they can go to the website and see that recording. Usually we post those things usually the following day after we finish up today. So, and also all of our past e-learning series have been recorded and posted there. So actually we kind of have a challenge for the audience. Our first e-learning series, we interviewed Charlie Jones and talked about, or more so predicted, rig count and things like that. And if anybody's watching rig count, I think they're going the opposite way of what we predicted. They're going down, and we figured they would either stay flat or go up. So I might have to go back and watch that one and see the lies that I told during that training. Of course, one other thing to mention to everybody is our chat functions live. So if you have any questions for JD or myself, feel free to mention them in the chat. We'll talk about them throughout the presentation. So if you're curious how long JD's been growing his mustache, that might be a good question to ask, or anything technical with plunger lift too.
Yeah, so forever.
Since birth. But perfect. JD, you ready to
let's
join
get started.
The presentation? Perfect. And guys, if you have any questions, feel free to throw them up in the chat function, and we'll answer them as we go through. So, JD, another e-learning series. So this one today is about plunger lift, more of a 101 course, going from well selection to equipment selection and the applications of plunger lift. We'll add a 102 later on this year, and that'll take what we built on this presentation and go more more into like optimization and troubleshooting. So we'll touch on that later on. But yeah, like we talked about, really want to talk about those cycle times, how you control a plunger lift, how you pick a well that could potentially be a plunger lift candidate over, say, gas lift or rod pump or something like that. And then we'll also dive into some of the equipment that we see out there in the market. So yeah, with that, let's get started. So just kind of get everybody up to speed, JD, talking about what exactly plunger lift is, right? So plunger lift is another form of artificial lift. What it does is it essentially utilizes the plunger, right, to be an interface between your liquid column that you're trying to evacuate from the well and the energy or the gas providing that drive to get the plunger and that liquid column up to surface. The way I like to look at it in my simple brain is it's basically a pig for your production tubing, right? So, and these plungers come in all different forms and sizes. And we'll talk a little more in this presentation about the different types of plungers that you would use to act as that interface between the column of liquid you're trying to get removed and that gas energy lifting the plunger below. So, and then with that, here's just kind of a little schematic, right? So when we talk about plunger lift, or really just any kind of production, if we look at it from a natural flow standpoint, this is typically what we see, right? This is a slug flow regime. We may also see a annular mist flow regime, and it basically just defines your fluid gas characteristics throughout the wellbore. Well, when you're in either slug flow, as we have depicted in this picture, or annular mist, you get a lot of liquid holdup and fallback, right? And so when we introduce the plunger into that style or type of well, that plunger just essentially minimizes that liquid holdup and fallback, right? And so it acts as a seal to hopefully evacuate all those fluids out. And a cycle is what we're going to talk about, but essentially just a bite of fluid that it pulls it out, right? So that's what we're going to talk about today. We'll dive into, the application and the operations of the system. So the plunger itself is this little piece here is essentially free falling throughout the well, right? And so its life or its cycle begins at surface and what we call the lubricator, and then it's allowed to fall through your production tubing and then reaches the bottom, typically a bumper spring, right? Once it reaches bottom, depending on plunger type, it can either stay on bottom for a period of time, in a case like conventional plunger, right? Or once it reaches bottom, it can close a bypass valve and then travel back up to surface. So that plunger is acting as that interface, carrying those liquids up every time this plunger arrives back up to the surface.
And the flow of the well is what brings it back to the surface in that case, right?
Mm-hmm. The energy provided from the gas, either formation gas or injection gas or a combination of both, right? Depending on what we're looking at from plunger lift standpoint. Yep, good point. And up at surface, included with the lubricator, is typically some kind of electronic controller. This is going to register when the plunger arrives. It's going to dictate the cycles, things like that. One interesting thing, and I know you've seen it from your past experience, is the improvements or the changes of this controller, right?
Absolutely.
It used to be just a old kitchen dial timer, right? That would switch from one cycle to the next. Nowadays, most of them are some form of PLC with their own algorithms and maybe some, machine learning that adjusts automatically based off of the feedback from the well. So, and that's what we'll spend a lot of time on is that cycles. And that controller here, no matter what style of controller it is going to affect or control those cycles, right? Another thing that typically is included with a plunger lift install or system is a arrival sensor. What are those sensors typically? Are they just magnetic electronic switches?
Yeah, magnetic, or sometimes they'll sense the density.
Okay. And then that's going to be set either on the wellhead or the lubricator, right? And when that plunger gets up to surface, that sensor will recognize that arrival and then provide that feedback back to that controller.
Right.
So, yeah, we'll dive into all that fun stuff. So really now switch from one cycle to the next. Nowadays, most of them are some form of PLC with their own algorithms and maybe some, machine learning that adjusts automatically based off of the feedback from the well. So, and that's what we'll spend a lot of time on is that cycles.
Yeah.
And that controller here, no matter what style of controller it is going to affect or control those cycles, right? Another thing that typically is included with a plunger lift install or system is a arrival sensor. What are those sensors typically? Are they just magnetic electronic switches?
Yeah, magnetic, or sometimes they'll sense the density.
Okay. And then that's going to be set either on the wellhead or the lubricator, right? And when that plunger gets up to surface, that sensor will recognize that arrival and then provide that feedback back to that controller.
Right.
So yeah, we'll dive into all that fun stuff. So really now that we've talked about how, the basics of the plunger, right? We'll get into a lot more detail, but I want to talk about the cycles, and the importance of the cycles, right? Because in my head, the way I look at the cycles, if they're optimized correctly, is it extends the life of the plunger, meaning that we're not wearing it out too fast. Hopefully it improves the production of the well, right? And allows us to get feedback on like the health of the system. Is that right?
Yeah. And helps prevent breaking equipment at the surface, your lubricator equipment, or even your bumper.
Good point on that. Because what happens is since this plunger is essentially free traveling, you're saying that sometimes it may travel too fast up to surface at too high of a velocity, and that could damage the lubricator itself, which is not good, right? Or it could damage the plunger. Typically just breaking it? Is that what you see?
Right. Yeah.
Okay. Just material fatigue from those impacts. Okay. Perfect. So when we look at plunger lift, JD, the first cycle we want to start with is what we call a close or off cycle, right?
Right.
And so what does that really mean when we talk about a close or off cycle?
So in the closed cycle or off cycle, there's a lot of different terms.
Yeah, and that's one thing to point out is that each operator and each vendor and each person may have a different term for the same function.
Right. But what's important to realize is just what's happening there is we're manually closing the well. Typically, historically, it's been a motor valve, Kimray or something else.
And that's usually over here on your flow line, downstream of the wellhead.
Correct.
Right?
Correct. Even just a few feet though.
Okay.
Typically. And so what we're doing is we're using our electronic device to close that actuator and just shut the well in. And then just due to gravity, the plunger falls.
Right. Okay. And then when that's being closed, that's either electronic or a pneumatic valve.
Yeah, historically it's been pneumatic, right? But as we see the industry make shifts trying to get rid of emissions and whatnot, a lot of it's going to electronic.
Because the pneumatic ones typically vent off from that supply gas. And that supply gas that's used to control that can come from where the casing, separator.
Wherever you have dry gas, it's really important that that's dry gas.
Dry gas, okay.
If you pull it off the flow line somewhere or off of kind of a wet supply, you can cause either the electronics in the box to malfunction or the latching valve in there or something to go out.
Gotcha, because of those liquids in the gas. Okay. And I've seen some operators where they just use compressed atmospheric air, right, as their supply gas.
Yes.
So you can set just a small compressor on location and provide that. So so like JD mentioned, all plunger lift systems are going to start with some form of close or off time. And like you mentioned, that's going to allow gravity to take over to pull that plunger down. And then also depending on the style of plunger, sometimes you can have this plunger begin to fall against flow once they open the system up. And that would be like a continuous flow or a bypass style plunger.
So with a conventional plunger, just to kind of get it all, with a conventional plunger, it has to be shut in for that. And we'll see it in a minute as we get farther in here. It has to be shut in for that plunger to fall to bottom.
The well has to be in a static state.
Correct.
To get that plunger from here, point A, to point B.
because it's just falling with gravity.
Okay.
And so then we're using that time to build energy, especially in older marginal wells.
Mhm.
You know, it may take the plunger 30 minutes to get to bottom, but it may need to build that energy in the reservoir for an extended amount of time. But then with a bypass plunger, since they can fall against flow that we'll talk about later, we're just shutting it in long enough to let that thing build the velocity to start falling against the flow. So anywhere from 10, 15 seconds to maybe just a couple of minutes.
Okay, good to know. So system's going to start off in that closed or off time. And then once that usually time has expired, right? Hopefully the plunger's on bottom for conventional. And then if for a bypass or continuous flow, it's gained enough velocity, falling velocity to overcome that gas velocity that's still being produced.
And you mentioned time. There's a lot of different ways to do it. I think for 101 today, it's good to kind of stick with time for the time allotment we have, 30 minutes. That kind of keeps it in a nutshell. Yeah. So there are a lot of ways to do that.
Okay. So outside of time, you could do pressure or flow volume, right?
Well, we're shut in. So you could do casing pressure build. You could do tubing pressure build. You can do what we call load factor, which is a differential between the two of those. You can look at line pressure even. There's just so many ways.
Many other. Okay. But that's good to note that time is not the only function to do it on. Okay. Perfect. So wells has switched cycles. We've moved from closed or off time to open, or I guess we could also call this on time, right?
On time, arrival time, lifting time. That's all kind of industry terms I've heard.
Okay. And what's happening during this cycle?
So during that, we've now opened the motor valve or whatever it is at the surface.
Over here on the flow line.
Correct.
Right? Okay.
And now the well has begun to flow. So when the well begins to flow, now the flow of the well is bringing that plunger up, right?
Okay.
So
and hopefully it's got
across that plunger, and hopefully it's got a column of liquid above it. And open time is how long we're allowing that plunger to come up. So if we've got 45 minutes, that plunger may arrive in 30 or 20 minutes. That's just our safety feature, if you will, so that if it doesn't arrive during that open time, it signals our controller, it signals our automation, whatever it is, and lets us know there's a problem and the plunger didn't arrive. And then we can opt as to what we're going to have the well, how we're going to have the well react after.
Okay. But typically your open or your on time is going to exceed the time that it takes that plunger to arrive to surface. Always. Okay. And that's fine for a system to do that.
It has to. If it doesn't exceed it, the well will then typically shut back in once that time expires. So if it takes 20 minutes for the plunger to run, but we've got it set at 15 minutes, we're never going to have a plunger arrival.
That makes sense.
So if it's typically a 20-minute run and we have 30 minutes in there, well, then the plunger will arrive in 30 minutes and then go to the afterflow that we'll speak about next. Or if it doesn't arrive during that time, we know there's a problem. And that's
what we call a missed run or missed arrival.
And in a conventional plunger situation, that helps avoid loading the well up.
Right. Because if the plunger's not coming up, it's not bringing fluids up.
Right.
And those fluids are just continuously stacking in the well. That makes sense. Okay. And then again, just like off time, we're going to talk about it from just a time perspective, but there's other ways to control that too. Or is that one just typically time?
That one's almost always time.
Okay. Perfect. And then so after the plungers arrived, that arrival sensor then tells the controller like, hey, plunger's up at surface.
Yes.
And then we go from there into what we call afterflow, right?
Afterflow.
And so afterflow, depending on the style of plunger, it could either stay in the lubricator or it could start falling back down, right?
My preference, this is where it could get a little bit
and this
subjective.
Goes back to your experience.
So with a conventional plunger, it's just a solid piece of metal, right? So, and we'll get into that shortly, but the flow of the well holds it up. Just it can't fall against flow.
Yeah.
With a bypass style plunger, at that point when it hits the lubricator, whatever bypass mechanism you have, whether it's a ball and sleeve or a dart, it has shifted back open, so it could potentially fall during that afterflow.
Yeah.
I prefer in that case to have an auto catch on the lubricator so that we're controlling the fall, just because that helps us get better data in the future.
And that auto catch is a feature that you add to a lubricator.
Absolutely.
And that auto catch there just mechanically holds the plunger in place, even though it's open and could fall. it just physically won't, because that
Right.
catcher is essentially catching the plunger.
Right, and there'll be a picture of one later.
Yeah,
that
well,
we
that's
can-
right. We'll talk
we can
about
do.
that. Okay, so those are the 3 cycles, right? We have off time, on time, and then after flow. And then here we kind of summarize it, right? So again, in today's discussion, we'll talk about time, but it's important to make everybody aware
Yeah.
that you can optimize
There's
those cycles off of other
a
data.
lot of
besides
data,
time.
whether it's critical velocity, whether it's pressure, whether it's pressure build. And it's important to note there. So we went close time number 1.
Yep,
Open time for the plunger to come up number 2.
yep, to come back up.
3, we say the plunger arrives, so then it would go to afterflow. But we do have
If
a
the
3.
sensor recognizes that plunger.
If it doesn't, at that point, oftentimes we have what we call a mandatory shut-in or a mandatory shut-in. But
Okay.
it basically, that's a different setting where if, say, your well's going to load up or we don't know what's happening, that well can shut in indefinitely, or it can shut in maybe for an extended period of time to help more energy build. But whatever that is, it's not always used, but that's an option.
Okay.
Is that mandatory shut-in. If we don't have that in there, then it will just start a cycle over.
Okay, that makes sense. And of course, in our Plunger Lift 102 course, we'll
Right.
talk a lot more about it. But each one of these features is one, adjustable. So the operator or the plunger technician can make changes.
Absolutely.
And then 2, you can use this data to track how well your system's optimized, right?
Right.
Okay, so that's something good to know, is that with like an operator SCADA system, well, one, we probably want SCADA on these things, right? So we can
Right.
record and see that data, but they can use that data to understand how well the system's running.
Right.
Okay. Perfect. Yep, that's really great information. So those are your typical cycle times, right? That's how the system's going to work, all fully adjustable. And that can give you an idea of how well your system's running.
Right.
One thing I like to bring up that I see with this too, that we didn't talk about, is typically production should be tied back to those cycles.
Right.
Because I see, and I'm sure you've got a lot more experience, I'm sure you see this, where a system is being optimized off of cycles and not necessarily production, and that both of those tend to need to be tied together, right?
Right, absolutely.
Yeah.
Yeah, one of the biggest problems typically when we put on a plunger system with a group that's maybe not as educated or experienced with it,
They need to
People will
join
get
the
very-
e-learning
yeah,
series.
people get very concerned with strictly the arrival of a plunger. Hey, my
Mhm.
plunger's running every time.
Yeah.
But if we're not paying attention to those times, we could be either breaking equipment or
just prematurely
Right.
wearing it out, right? So in my head, I like to view this almost like a insert pump on a sucker rod pump, is that you can pump its cycles per minute more, but you might not get more production. But instead, you're just going to wear out the barrel or the rods or the tubing. Plunger lift's similar, right? Is that you could get too many cycles to the production you're getting, and then at that point, you're just simply wearing the plunger
Right.
out, right? Okay, perfect. So now, JD, let's move into selection. How do we know a well's a plunger lift candidate? Especially when we're looking at ESP or gas lift or sucker rod pump or jet pump. How do we, almost cull out those other types of artificial lift to decide this is a plunger lift candidate?
Right.
Yeah.
So obviously we have here any wells that are below critical velocity, slowly loading up, wells that we see, if we don't have a packer, we see that casing pressure rising.
On the backside?
That indicates liquid feeding into that backside, compressing the gas that's back in the annulus, and we're seeing that as a pressure build at the surface. Wells that you vent or swab, even if it's every other week, or shutting it in for an extended period of time, anything like that is oftentimes a good candidate, or an indication it's a good candidate.
Okay.
Or any well on gas lift, and I don't know how much we'll get into this today, we'll hit on it, but I've been asked a lot, when is a gas lift well ready for GAPL?
Okay, so going from continuous gas lift
So
to gas assisted
and so we'll kind of give, but wells with gas lift, I've seen a lot of improvement on the, efficiency from adding that plunger. And then anything with paraffin or scale buildup, we've seen that a lot.
Because the plunger is essentially wiping the tube
Right.
walls.
You mentioned a pig earlier,
Yeah.
right?
So it's clearing that paraffin or scale
Right.
buildup.
And for me, the last 13 years almost has been spent primarily in the Eagleford, but some other South Texas plays too. And some of that Eagleford stuff, our initial reasoning was strictly put it on gas lift wells because paraffin can be an issue there. And then from that is where we kind of started seeing the other benefits of decreased injection and even lower flow and bottom hole pressure.
Okay, good to know. Yeah, and we'll talk about that.
So, but the main thing as we go to the next slide here, that is that indication of if it's a good candidate. So we're doing all these. Gas is your energy that drives a plunger. So the well has to have an adequate GLR or be at a close enough to critical velocity, because that plunger in and of itself has no energy, right? We shut it in, it just falls.
Yeah, we have to have that reservoir energy to ensure that it works.
And that's where that comes into play. So GLR is that big, that big driver. The quick rule of thumb, this chart's kind of busy, but the easiest thing is about 400 cubic feet per barrel per 1,000 feet of depth on conventional plunger lift.
Okay.
And that there's a lot of other factors. If you do that with 500 pounds of wellhead pressure, it's obviously not going to run.
Correct.
But really, just in a nutshell, that's kind of a quick way is to look at that GLR. Something I often say it's not on here is a 5,000 GLR.
Okay.
It's standard cubic feet.
Is the minimum you want.
It's the minimum you want. Okay. Anything over that gas is our energy, right?
Right.
So that's the minimum. Anything over that will definitely run a plunger.
Gotcha.
So that's just if it will. Where I do break that rule personally, and this is where something you can give feedback to, on a bypass style plunger, that plunger falls against flow. We're only shutting it in for a few seconds if necessary. We're really never shutting that well in to build energy. So we're just sending that plunger down. It's getting a bite and coming up, and the well is continuously flowing. I focus more on critical velocity at that point.
Okay.
So when we calculate critical velocity, however we decide to do that, typically I see if we're at about 65% or better of critical velocity. Like I said, at Eagleford, South Texas place, I almost throw GLR out the window.
And you look at critical.
And I look at critical because.
And that makes sense because most Eagleford wells or conventional South Texas wells are going to be flowing in an annular mist flow regime to begin with. So you're going to have a lot of little droplets plus some kind of capillary flow of your fluids against the ID of your tubing walls, right? So you're looking at that critical velocity to make sure you have enough energy to carry that plunger, and as it accumulates fluids on top of it as it travels up to surface, to make sure you can overcome your wellhead pressure plus your gas weight plus your hydrostatic to get that plunger and that fluid up to surface. Yeah, and that's a really good way to look at it. And I could see in these gassier plays that critical velocities a really good application. I like the GLR function more for like your oil plays, like a Bakken or a Permian or Delaware Basin, where we're typically going to be in a bubble flow or a slug flow regime, and usually a little lower GLR maybe. And then with that, we can use that gas to liquid ratio for anybody that's unaware of what a GLR is to help pick, primarily again with plunger assisted gas lift.
Yep. So to sum it up, with conventional plunger lift, about 400 cubic feet of gas per barrel of liquid per 1,000 feet of depth is a good judgment, assuming we're not bucking really high line pressure.
Right.
And then with a bypass plunger, similar GLRs and or 65% of critical velocity. Because once you get below that, if you're not shutting the well in to build that energy, then it's just not going to run anyway.
Yeah.
One quick thing to mention though, on back to conventional plunger, if we've got a packer in the well, you need to double that GLR, because without the packer, we shut the well in, like I said, maybe 30 minutes to an hour, give or take. It can vary a lot, but we're letting the plunger fall, but we're also letting the reservoir build the energy to drive that plunger to the surface. When we don't have a packer, when we shut the well in, what do we see the casing pressure do?
Typically rises.
It rises and so we're building energy also in the casing.
So we're building like a gas pocket in the casing.
Yes, and so now you don't only have the energy from the reservoir to drive that up. Your casing, your annulus there is basically a storage tank for that energy as well.
Yeah.
So the casing will help store the energy and help the reservoir itself. But if we put a packer down there, we isolate the annulus. The only energy to drive it is the energy from the reservoir. So in that case, the rule of thumb is doubling that G.
Okay, that makes sense. And so as an operator, they can look at well type packer
Absolutely.
list, and then also production or well test to help decide, one, what type of artificial lift they want to apply. And then if they do decide on plunger lift, they can use this information here to
Right.
decide the style of plunger.
Right. And it's very common too, if you have a packer, go in and punch a hole below wherever your bumper spring's going to be.
Mhm.
Now you've got that communication. Now that gas can access the annulus, and you've got that store.
Okay, and that's cheaper than having to get a workover rig and
Absolutely.
to pull just a packer to put the well in plunger.
Right.
There's one thing, we didn't talk about, JD, is the purpose a lot of times of plunger lift is later life wells.
Right.
And usually assigned to later life wells is production's typically lower. So most operators don't want to spend a lot of money for artificial lift. So it tends to be a pretty low cost
Right.
Artificial lift application as compared to like a rod pump or
Right.
ESP.
You just have to have that energy in the form of gas from your reservoir.
Okay, and that goes back to that well selection.
Yep.
Okay, great. So JD, thanks for that feedback. Let's move on to equipment.
Yep.
What do we need to put a well on plunger? If we've picked the well, looks like a good candidate, maybe off critical velocity or GLR, now we decide on
Right.
equipment. And
Yeah.
so these are some of the things we'll talk about. If you don't mind, I'll jump to the
Yeah,
next
just jump.
one,
That's what I was
so
going to
you
mention.
can-
Just go to the next.
Yeah. So first thing, what do we need?
Yeah. First, downhole, we have to have a bumper spring.
Okay.
So that bumper spring is just, cushioning that fall, something for that plunger to fall against.
Keeps it from falling out the end of
Keeps
tubing,
it from
right?
falling out of the end of tubing, or
Okay.
if there is a nipple, keeps it from just hammering in that nipple.
Gotcha.
Downhole, and we can set them in any way, right? You've got cup hold downs, basically like what you have on a rod pump.
And that's going to set in a profile.
That's going to set in a profile nipple.
Okay.
It can set in a seating nipple, which is smooth bore. It can
Mhm.
set in a profile nipple, and it doesn't actually fit that profile. It just seals off in the smaller ID of
Okay.
that. So it's still a 3 cup. It's not specific for an X or an R or whatever you've got, but it seals off in that nipple. So that's oftentimes the simplest and the most common way.
Mhm.
But if you don't have one, it's very easy. Collar stops are very common, and
that sets in the recess between two.
right. You have to have
connections of
EU
tubing.
tubing though, right?
Right. So if you have like a CS Hydril or
Right.
premium thread,
Right.
you can't run
There's
that
no
collar
gap
stop.
there, so you
Okay.
can't run it. So then the other option there would be a tubing stop.
Okay.
We have pictured
And
here. a
yeah,
tubing
here's
stop.
the tubing stop right here.
And we have
Yeah.
pictured here the tubing stop on the spring. My experience is that's not a great idea.
Oh, really?
Because that tubing stop just has slips, and the way you set it is you hammer down on it, and the more you hammer it, the more those
It
slips.
pushes
get in.
a slit into the wall of the
Right.
tubing.
And when you do it with a spring, that spring tends to absorb a lot of that hammer
That makes sense.
and that jarring you're putting on it. And
Yeah.
so typically when we run those, we'll run a tubing stop with just an 1 3/8 fishneck,
Mhm.
and then
On one slick line run.
on one slick line run,
Okay.
and then come down with just a collet latch down and just latch onto that.
Gotcha. And that's one thing too that we should mention. These downhole tools are typically going to be run via slick line.
Correct.
I have seen some operators where they want to drop them from
Yep.
surface. How do you feel about that?
I've got mixed feelings.
Okay.
It's not a good idea. If we're doing it for the first time, this is Plunger 101. I always push for, we want success on the first run.
Yeah, and we'll
So
talk
do
about
everything
the
we can.
installation here in a bit
You know,
too.
if your field guys are very experienced and they know what to look for, you can drop it from the surface. If it doesn't seat, you'll probably know it. It'll come back, and then you know what to do. So
Gotcha.
really, it's
Run slick.
it's ill-advised, run slick line,
Okay.
but I've seen it done a lot.
Okay, and I have too. So good question on that. So okay, so we set the bumper spring. It's
Yep.
cushioning the plunger. It's also keeping it from just simply falling out the end of the tubing. Now we need to look at the plunger style, right?
Right. So yeah, we've got continuous flow. So what we're doing here is we're kind of going in the life of the well. That's kind of the order we're putting these
Okay.
plungers in this presentation. So typically we start out, we're free flowing, then we either start gas lifting or the well just starts to deplete.
Mhm.
So initially we're flowing well above critical velocity.
Right.
But here, like I mentioned, I like to base bypass plungers typically in the fields I'm in. It works really well
Mhm.
off critical velocity.
Okay.
So once you fall, you're above critical, you get to 100%, we're still lifting. Well, once you bump below that, in theory, we're starting to slowly load up. So now we'll drop a bypass plunger. That bypass plunger, you can see there are slots at the bottom there.
Right here and here.
And the plunger is hollow through the middle. And
through this piece here.
Correct. And the fish neck is hollow up at the top.
Okay, so that is a question that I get asked. Can you fish these plungers? So this is the internal fish neck.
Correct. So it's easy to fish. And what's not pictured
and this is the bottom and this is the top,
absolutely.
Right? Okay.
Absolutely. What's not pictured here is there's a dart inside. And so there's a rod at the surface. So when that plunger hits the surface, the dart shifts down, and now the flow of the well has access to the slots we have.
So now it's also out of the top.
Yep, the plunger falls against it, and so that we can utilize that plunger, a bypass plunger, till that well gets down to what I call about 65% of critical velocity. Now there's just not enough flow at all for that plunger to come up to continuously flow it. So now we're needing to shut that well in and build energy for a little
bit. And then here in a few slides, we'll touch on those types of plungers that require a shut-in time. Okay, perfect. So let's stay on the continuous trend for a little bit longer. So one thing you mentioned was the slots that allow flow. So most of the time with any type of friction bypass style plunger, you can pick what we call our slot size, right? And you're going to usually base that off of your production rate.
Correct.
Okay.
Correct. So as you see here, I think we've got about 8 different slot sizes, 2 3/8, from 2 small holes, then they get slightly bigger, 3 slots, 4 slots, 4 wide, 4 extra wide, 5 slots. So there's a large range.
And you're sizing that based off of the flow.
Right. And the main thing for that, so when I do field trainings, which is kind of what I do primarily, the thing I try to beat into field guys is my number 1 rule is don't break equipment. And I've come to that because I've personally broken a lot of equipment. And then I see people break a lot of equipment. Regardless of how robust it is, you can break it if you hit it hard enough times, right? So a 2 slot, what do we have it labeled there for, say 1 to 25 barrels, and a 5 slot, just to jump to the extremes, we say from 50 up. Well, a 5 slot will run in a 2 barrel a day well. It's just going to fall much faster.
And that's where you can.
And that's where we're going to bring it. So
damage equipment. So you got to size that based on.
And what I try to do, my advice is always try to run find the smallest size slot that'll run in that well. Just because that helps us follow what I tell guys is my number 1 rule is don't break equipment.
That makes sense. Okay. And so this is going to be for your friction bypass.
Correct.
The other style of continuous flow is a ball and sleeve. This used to be the old pacemaker plunger, right?
Right. So a ball and sleeve, and this is where we get into the subjectivity of plunger lift, right? There are really good plunger guys out there that want to go to a ball and sleeve first. I'm on the opposite side of that. I try to go to it last. My reasoning for that is they are the fastest falling plunger we have.
Because it's just a hollow sleeve, right?
Just a hollow sleeve, and then you've got an 1 3/8 ball on 2 3/8 so they fall separately. A rod at the surface knocks that ball down. It falls independently. The sleeve falls independently when they meet up at the bottom, and then now they're sealed together and they come back.
This ball mates to the bottom of the And so in my head, a lot of times where I see ball and sleeves being used over a friction bypass is typically due to either sand or a lot of solids, right?
Correct.
Because it has less pieces to get plugged up.
Right. And everything is independent, right? So the problem with the clutch system, that it's caged in. So I've seen that whole clutch system packed full of sand.
Okay.
Also, even sometimes, even though it's sealed off pretty well, sand can actually get within that clutch mechanism. And that's where it can really get too stiff and either lock closed or lock in the open position.
And then it essentially fails.
Whereas the ball and sleeve, even if you've got sand in there, every time they come completely apart, they fall through that flow, typically kind of washes it off. So it's much better with solids. Also, they fall against higher rates.
Right.
So there are rates that a ball and sleeve will fall against that a 5 slot even may not.
Okay. So that's another option operators can look at for the continuous style.
Right.
Okay. So JD, let's move from continuous style to more of this, what do you call this? Intermediate style,
yes.
Gray area, I guess you call it.
Right. So we're kind of working through the progression because
and also we're looking at it as the well ages.
Correct.
And that critical velocity and volumes are trying to decrease.
So now we're below the critical velocity.
Okay.
That the bypass plunger will run with. We need some shut-in time.
65%.
Yeah, give or take, right? Okay. And this is, everything's very general. I don't consider plunger lift mathematic, right? Like
Yeah.
with gas lift, we can calculate the gradient. We know what pressures are. Well,
Yeah.
to me, plunger lift is much more subjective and due to experience, right?
Okay.
So, so the numbers are very rough, I would say.
Yeah.
But so now it won't run the bypass. We're below 65%. We need a little bit of shut in. Well, a conventional plunger, which is the opposite end of the spectrum,
And we'll see that
it may need 30 minutes to an hour just to get to bottom
because it falls
because it falls slowly.
Okay.
But the well may only need, say, 10, 15 minutes to shut in to build that energy to get it up. And that's where I use these, what we call a sliding sleeve or a center rod. It just falls faster, you know. Typically, what I feel like I've seen is 1,000 to 1,200 feet a minute.
Okay.
They have slot sizes
So on a
as well.
10,000 foot well, that's like 8 to 10 minutes.
Correct.
Okay.
So now we're shutting it in not long enough to hurt production, but long enough to get that to bottom.
Mhm.
There are operators and maybe other plunger people that run these as a bypass. I've personally not really had good luck
You
trying
feel
to.
like they require that close time to get to bottom.
And I'm a simple-minded. I like to do things as simply as possible.
Simple's the best way to do
And
it.
sometimes it's if there's less troubleshooting involved doing it, that's the way I like to go.
Okay.
So
That makes sense.
So yeah, the next step is a center rod or a sliding sleeve. So we're getting to bottom, and we've seen these have really taken off in the Eagle Ford.
Oh,
We're
really?
having a lot. One negative is you can't see it in the picture, but there's a shoulder on the fish neck that's really a weak point that other plunger styles don't have. So
Okay.
this could have the propensity to break when run
If you're not careful.
inappropriately.
Okay, that makes sense.
But we're having really good luck running a lot of these in the Eagle
Interesting.
Ford.
And this is pretty neat because it's not necessarily continuous. It's not really conventional.
Right.
It kind of bridges that gap.
Right.
Right. Okay. So now let's move into our conventional
Right.
now. So these require shut-in time to get all the way down.
Right,
the bottom,
right. So we were flowing close to critical. We were running a bypass. We got below that, needed to shut it in for a few minutes to build that energy.
Yeah.
Now the wells continued to decline. We're later in the life of the well. It might need 30 minutes and plus, you know, for build. So now we go
to
to
get that
conventional
energy to return that plunger back to the
Correct.
surface.
Correct. So then we go to just a conventional plunger. No need in running a center rod plunger
Okay. Mhm.
that gets to bottom in 8 to 10 minutes if we've got to shut it in for an hour.
These
anyway.
have really good seal, right?
Correct.
And
So-
that's why they fall so slow because their seal is so good.
Right. So you can see there the three on the left are padded
Pad
plungers.
And those pads have springs behind them, right?
Correct.
They can flex with the idea of the tubing.
Correct. And they you know, out of the well, they extend farther than the idea.
Right.
Of the tube.
Okay. And that's going to be your sealing surface on
Correct.
the plunger. Okay.
Correct. And it's a balance there on the selection. You see there's different lengths,
Yeah.
different
1,
pads.
2.
The
and
longer a
like
plunger,
3.
the better the seal.
Yeah.
The more pads, the better the seal. The better the seal, the slower the fall.
Mhm.
So it's kind of that art of knowing your well, knowing what you need.
Yeah.
Sometimes you need a better seal.
Okay.
There's a large selection in there.
We talked about solids earlier. So if you had to pick a well that made a little sand, would you go with a pad plunger or one of these bar stock style plungers if you had some solids in the well?
Right. So typically, if you have solids in the well, sand building up different
Mhm.
places, that sand can get stuck behind those pads.
So it can migrate in
And-
behind.
And
that
so
pad.
what can happen is those pads will stay extended and
Mm,
stick that plunger.
Okay.
So typically, if you have solids or anything else, you need a bar stock style.
which is this style
something
over
like
here. Okay. And again, too, just like the bumper spring, if an operator ever needs to get one of these out of the well, maybe it's stuck,
Right.
or maybe it wore down too much to where the seal isn't enough and you're just getting all that energy bypassing, they can come in with slick line
Yep.
and fish that out,
Correct.
right? And this is the fishing neck that slick
Right.
line can get attached to. Okay. Perfect. So this conventional, it requires shut-in time. You have to shut it in the whole time for that
Right.
plunger. And, looking at shut-in times, depending on how slow it falls and how much energy you need to build up, that defines that close time cycle that we
Right.
talked about earlier.
Right. And you're talking about how long does it fall or does it take? Typically, we kind of calculate or guesstimate, say 200 to 250 feet a minute.
Okay.
But that's a rule of thumb again, because once it hits liquid, it's going to slow down tremendously.
Yep.
And then what kind of liquid is that? Are we talking just water? Are we talking about oil? What's the
Mhm.
gravity of that oil? What's the mixture? So it can really vary a lot.
So if we need the benefit of a conventional plunger, but maybe we need it to fall a little faster, that's where we see this style of conventional plunger.
Right. And the only difference here is you can see there's a few holes just under that fishneck at the top.
Oh, right up here.
So that plunger is hollow through the middle.
Okay, from the bottom up
Correct.
to this point.
Correct. And so that just allows a little bit of flow through, kind of lesser than that center rod we saw.
Yeah.
But so it'll get to bottom a little faster.
Okay, so if your reservoir build time exceeds the fall time of the plunger, meaning that it'll build up faster than the plunger gets to the bottom, you would want to run this style of plunger.
The negative here, though, as you can see,
it has holes.
There's the trade-off, right? With everything you gain, you kind of maybe lose something. So here we get to bottom quicker, but we do lose a little of the efficiency of that plunger because it can kind of come through.
Okay.
Sometimes that can offer kind of an aerating effect where maybe it lightens that load above it and kind of can help it. But sometimes that's just giving you some slippage.
Yeah.
However, if a well's building that energy quick enough, a lot of times you're kind of okay losing that efficiency, right? So that's where that whole trade-off on plunger comes.
Okay. And to be courteous of time, one thing I want to note real fast on this is we talked about just your general plungers. There are modifications that can be made based off of like specific situations.
Oh yeah, there's all kind of, here you see the diamond cut. Those are good for cutting through scale or paraffin buildup. And there's so many different kind of options within each one. We don't have time in plunger 101 to go through.
Well, and you and I both like to talk, so we got to be courteous to everybody's time. So we talked about this, right? Typically, based off of the well flow, you're going to start off with some kind of continuous flow or bypass, move to maybe a slide and sleeve or a fast fall, and potentially end up on a conventional. And depending on basins and operator things, a lot of times you can see plunger lift act as the end of life artificial lift. Like in Barnett, I'll use the example as that's been the end of life for Barnett wells for what, probably the last 10 years. And most likely will continue that until they are PA'd. So good point. So a couple more things before we wrap up. JD and I both like to talk. So we got to be careful of that. So we talked about the downhole equipment. What do we have at surface for a plunger?
So here you see we've got the lubricator,
which is this blue thing here,
and
it's attached to the top of the wellhead.
Yep, straight to the top of the wellhead. The one here pictured looks like it's about a 3K operating
pressure.
So that's
a low pressure lubricator.
Right. We have 5K, 10K.
And you typically match those to the wellhead.
Yeah, whatever the operator requests, because obviously you've got higher costs with higher pressure ratings. So then it just comes off. You're coming off the dual outlet
here and here.
Yes.
Right.
And now you're just to your hairpin or your flow line. We've got the motor valve there that we were mentioning earlier.
And that's that pneumatic control valve you're talking about. Okay.
And then there looks like a controller mounted on the front of that. There. The other thing you can see, that's the auto catch that looks like the Kimray top.
This device over here.
So in this case, it's also pneumatic. So it's just tied straight to your motor valve that's on your flow line. So when the motor valve opens on the flow line to allow the plunger to come up, that one just closes.
So this one opens, this one closes.
Right, and all that close is doing is protruding a ball into your lubricator for a friction bite on that. So.
Okay, and again, just like this control valve being pneumatic or electronic, this can be electronic as well, based off of emissions and supply and gas. Okay. And then, like you mentioned, this is a low pressure one. You can typically match these to your wellhead pressure, to your flow line design. So you see a lot of customizable with the lubricators. Perfect. One other thing I like to talk about too, JD, with the surface equipment, right, is matching our lubricator and our plunger to our wellhead configuration.
Right.
So typically, if we're 2 3/8 tubing, what size wellhead do we want to have on
you've got to have that 2 1/16 wellhead.
Okay.
If you oversize it, that plunger's going to lose a seal when it gets
once it gets there,
and it won't come up to the lubricator.
It'll just kind of hover.
It'll hover down there.
Okay.
And with a bypass plunger, it has to go all the way to the top to shift the bypass mechanism. So it's just I'm not going to say it's impossible, but it's not ideal.
Not recommended.
And then on the opposite side, if you've got a 2 1/16 on a 2 7/8 well, I think logic tells us all that
we're not going to get the plunger to fit.
That plunger's not going to fall very well.
So you worked down in Eagle Ford quite a bit. So this is probably a common style of wellhead, right? How do you feel about, what do we have? 3 master valves, a flow block, and a swab valve.
Yeah.
Is the height of the wellhead, does that affect anything?
It absolutely does, because you are losing some seal in that wellhead. So every valve you have to go through loses efficiency.
Okay.
I used to try to convince people to just have one master valve, put it on top, which is kind of how I came up in older conventional wells, right? Well, I don't necessarily agree with that anymore. The safety of at least 2 is pretty good, especially in these major plays, right?
But a lot of times you can remove that flow block.
It's preferable to remove that flow block
and put your lubricator there.
Put it right there, and then reconfigure your hairpin from
there. That makes sense. So something to look at when an operator's considering plunger lift, probably do a well site visit.
Absolutely.
And go see the style of wellhead. Okay, that's good to know. Perfect. Thank you, JD. One last thing before we wrap this up is we've talked about the downhole, talked about the plunger, we've talked about the lubricator. What do we do to get all this stuff installed, right?
Like I said, it's always good. Get slick line out there first.
Okay.
I always suggest the very first thing, get out there with slick line and run a gauge ring
to make sure the ID of the tubing is concentric.
Right.
Okay.
And do that before you even reconfigure that wellhead, because too many times I've seen we put a lubricator on a wellhead, we've got a tight spot, we can't get through the tubing.
And the operators invested all the money and time. Okay.
So I like to suggest run a gauge ring first, then go in and set your bumper spring. If you need to hot oil, if you've got paraffin, do that obviously before, or cut the paraffin. If you're doing gas lift, we're not talking about GAPL a lot, but also I suggest running a survey, because even if our
flowing pressure temperature survey,
flowing pressure temperature survey, and getting a good one, because even if the casing pressure indicates we're on bottom, we all know that's not always accurate.
Might have a hole in tube.
Right. And if we set the bumper spring below that point of injection, then the plunger will not run, or at least won't run consistently past that injection. There's a lot of turbulence if I'm putting 400 MCF in 2-inch, tubing. So the plunger just won't come back past it. So I always suggest run a survey. What you can do there is if you are injecting higher up the hole than we expected, we can kind of run the economics. Do we want to work that well over with gas lift first, or do we just want to set the bumper spring above that point of injection and run it from higher up the hole?
Okay.
So depending on
it allows you to make that game time decision on what you want to do.
Right. So run slick line, set the bumper spring, then reconfigure the wellhead, then drop the plunger and get going. If you did hot oil it, sometimes we need to flow it for a day, give or take, because to get all that water off of, or oil, whatever we pump down it.
Okay, that makes sense. So and I like your thoughts about do the slick line first before you invest the time and money for the surface equipment. If you prep your downhole, then you can come back with the roustabout and do your surface setup and be good to go. Okay, perfect. And JD, thank you for the content and going through this presentation with us. Before we jump into Q&A, just want to remind everybody about our upcoming other e-learning series. Next, we're going to dive into capillary tubing, how you maintain it, how you apply it, downhole gauges as well. And then we're going to get back into that Plunger Lift 102. So we'll get into optimization, troubleshooting, those types of things, and then wrap up with plunger assisted gas lift. So with that, we'll end the presentation and open it up for Q&A. We'll get a quiz, JD, on how knowledgeable he is.
Yeah.
So thank you, JD. So, couple questions for you, JD. One of the questions that we see a lot from operators everywhere is, will the plunger, as it travels up and down the tubing string, does that actually wear out the tubing like, say, a rod pump system does? You ever see that?
I haven't, but I know that our Barnett team sees that in the Barnett. I think we're actually building plungers oversized at this point for the Barnett, where they've been running plungers. I used to really be concerned with that, but as I've kind of just heard that, yes, it can. Typically, we're seeing plungers wear out first. And if you look at these Barnett wells, I would be interested in how long the tubing's been in those wells. But I mean, Yeah, yes, it can, obviously, but I haven't seen that ever really be an issue that would override a plunger being the best option as artificial lift for that
Okay.
well.
Okay, perfect. Another question we had was when it comes to the installation. So slick lines already run a gauge ring, maybe broach through any tie spot, set the bumper spring. Do you chase the plunger down with slick line as well, or do you typically just drop that from surface?
I like to chase it down.
Okay.
Often you get a broach through for some reason, and maybe the plunger's 3 inches longer
Mhm.
or something, and we're having issues. I think it's best if you got the time to do it.
Usually slick line's still out there.
Right. I think, I mean, typically there's not a reason not to. So
Okay.
I think that is
So
best.
chase the plunger all the way to the bottom with slick line. Once it's on bottom, slick line can pull out,
Yep.
and then you can bring the well on
Absolutely.
to production. Okay. Another question to the installation side is sometimes you hear people talk about running a cleanup plunger after install, where maybe they run a
Yeah.
different style of plunger versus what they would run for like the life of the well.
Right.
When would that be a good
Yeah,
application?
I mean, obviously, I think the main time I've seen it, and this is one of those things, maybe it's area specific, so there's
Mhm.
probably some input that maybe I don't have, but what we see a lot in the Eagleford is putting that plunger in initially. Sometimes there's a little sand, a little solids, especially you're getting a little bit more drawdown.
So you're starting to bring in some of those solids that you typically don't see.
And often if we put a different, we either will free flow the well for just a little bit longer.
Which can clean it up
Yeah.
too, right?
Or maybe put a ball and sleeve plunger in there for a little while, even though I personally don't like them. Put a ball and sleeve in there, maybe get it cleaned up, and then can change back.
Okay. And that's something simple that artificial lift tech or pumper or a plunger lift tech can go out and do.
It's not something it's usually a reaction, not something we're doing ahead of time, in my experience personally.
Okay.
Just so but if sand's a problem or solids are a problem, that then we explore other options.
Okay. All right, perfect. All right, so $1 million question. I get this one all the time. How do you define paggle and gapple, and are they the same thing?
I think the industry
Put you on the spot.
Yeah, okay, so my answer used to be, it just depends on which one is on the well first. If it's plunger on there first, then
as the main artificial lift.
Right. If you had a plunger and then had a gas lift, I called it gas assisted plunger lift.
Okay, gapple.
If you had gas lift first, I called it plunger assisted gas lift. But I think the industry has started to kind of, I don't know if there's an actual definition, but it seems like the industry kind of has started defining it itself. So I think what most people, what I hear and what I kind of refer to now is if we're running a bypass continuous plunger, so continuous gas lift, not shutting the well
injection.
Continuous injection.
Okay.
Then we're doing paggle.
Okay.
Plunger.
I'm gonna get you on this one.
Because the plunger is assisting gas lift at that point.
Right.
Then if we're doing a conventional plunger, shutting that well in and for 30-40 minutes letting it fall to bottom, and that time frame is because I'm in the Eagleford, and that's kind of standard for us, right?
Okay,
so if you're in a different play, or
it may be more, it may be less.
It could be different.
Okay.
But we're shutting it in for 30 or 40 minutes, and then we're using that gas lift to help get that plunger to surface. Then we call it gas assisted plunger lift.
Okay.
And there's a lot of ways I see that done, from injecting during your shut-in cycle to build the energy, and then letting that built up energy in the casing blow that plunger up. So we gas assist it that way, or leaving it shut in during shut-in time, leaving sometimes that's the simplest. If you don't have automation, you shut in the casing and tubing at the same time, stop injecting, and then open them both up, and you're injecting at that time.
Okay.
And I've even seen it where we've kept injection going the whole time. That does build casing pressure, but it seems like so. But that's what I would call gas-assisted plunger lift.
Okay.
I think.
That's helpful, because that's a question that we see quite often, and defining the differences. Sometimes operators use together, and then other times, like you mentioned, I think the industry in the whole, at least in the North American resource plays, are starting to see and understand the differences, especially as these wells age out over time, and maybe because of infrastructure or well type may not want to go to your other end of life artificial lift, which is typically rock pump. So perfect. Well, JD, thank you so much. Thanks for the content and your knowledge and expertise on this. And everybody, thanks for joining. And like we said, we'll record this. So if anybody had to get off early or have somebody else that may benefit from it, we'll have that posted up on the website.
All right. Thanks for having me, Matt.
Yep. Thank you, JD. Thanks, guys.